If you throw a heavy wooden log onto a campfire, it burns. If you throw a cup of gasoline onto that same fire, it explodes. But if you throw a bucket of water onto the flames, the fire instantly dies. Why? You probably think water puts out a fire because water is wet and because it is cold. That is a comforting kindergarten explanation, and it is completely, utterly, fundamentally wrong. If you ask a normal person why water doesn't burn, they will look at you like you are crazy. But it is a profound physics question. Gasoline is a liquid. Alcohol is a liquid. They burn beautifully. So why not water? The answer is going to completely shatter your everyday reality. Water doesn't burn because water is already burnt. You are bathing in, swimming in, and drinking the chemical ashes of one of the most violent, explosive reactions in the universe. By the end of this video, you will understand exactly what water really is at the atomic level. You will discover the terrifying reason why it suffocates flames, and how you have been entirely misunderstanding the liquids you interact with every single day. Your intuition is about to be destroyed. Let me show you. Let us start by addressing the lie of wetness. When you see water extinguish a flame, your brain immediately associates the physical sensation of a liquid with the stopping of fire. You think liquids coat things, they smother things, they are wet, and wet things do not burn. But wait a minute. Is that actually true? Go into your garage, take a cup of liquid gasoline, and pour it onto a match. Does the wetness put it out? No. It creates a catastrophic fireball. Go into a laboratory and pour liquid hydrogen onto a spark. It detonates with enough force to level a building. Wetness has absolutely nothing to do with whether something will burn. Liquid is just a state of matter. To understand why water is immune to fire, we have to stop looking at the puddle, and we have to look at the atoms. We have to ask, what is fire in the first place? Fire is not a substance. It is not a glowing fluid. Fire is a catastrophic runaway chemical reaction, and the main instigator of this violence is oxygen. Oxygen is an incredibly aggressive, incredibly hungry atom. It is desperately searching for other atoms to bond with. When oxygen floats around in the air, it is relatively stable. But if it gets close to an atom like carbon or hydrogen, and you give it just a tiny spark of heat to get it started, it attacks. The oxygen atom violently snaps together with the carbon atom. And when I say snaps, I mean it is a brutal high-speed quantum collision. Imagine a massive, heavy boulder sitting at the very edge of a steep cliff. That boulder has a huge amount of potential energy. It wants to fall, but it is stuck in a tiny rut at the top. If you give that boulder just a tiny push, a spark, it rolls out of the rut and plummets down the cliff. It smashes into the valley below with terrifying kinetic energy. In chemistry, the top of the cliff is the unburned fuel, the wood or the gasoline. The push is the match, and the violent crash at the bottom of the valley is the oxygen snapping into the carbon. When those atoms snap together, they vibrate violently. They jiggle. And as we know, atomic jiggling is what we call heat. That heat bumps into the next atom, giving it the push it needs to fall down the cliff, which creates more heat, which pushes more atoms. That runaway cascade of boulders falling off the cliff, that is a fire. So, what does this have to do with water? To understand water, we have to look at the most violently aggressive fuel in the entire universe. Hydrogen. Hydrogen is the smallest, simplest atom in existence. And because its electron is so exposed, oxygen desires it more than almost anything else. If you mix a room full of hydrogen gas with a room full of oxygen gas, they are sitting at the very highest, most precarious peak of the energy cliff. They are desperate to combine. All it takes is a single spark, a fraction of a degree of heat. The moment you provide that spark, the oxygen and hydrogen atoms snap together with an apocalyptic ferocity. The energy released by this specific collision makes burning wood look like a joke. When hydrogen and oxygen burn, it is the ultimate detonation. It is pure, unadulterated thermal violence. But here is the most important question you will ever ask in physics. When the explosion is over, when the terrible heat dissipates, what is left behind? What is the physical byproduct of hydrogen and oxygen snapping together? 2 hydrogen atoms and 1 oxygen atom, H2O. Water. Water is the chemical ash of a hydrogen fire. Look at a piece of wood that has burned completely in your fireplace. What is left in the morning? A pile of soft, gray, lifeless ash. If you take a blowtorch and hold it to that gray ash, what happens? Nothing. It doesn't burn, it just gets hot, and then it cools down again. Why doesn't the ash burn? Because it has already fallen down the cliff. It is sitting at the absolute bottom of the energy valley. The violent collision has already happened. The energy has already been released. You cannot burn ash because burning is the act of releasing energy by falling down a cliff. The ash is already at the bottom. The universe is inherently lazy. It always seeks the lowest energy state. Water is exactly the same as that gray fireplace ash. When you hold a glass of water, you are holding the exhausted, spent, perfectly stable remnants of a violent chemical explosion. The oxygen and hydrogen are locked together in a deep energy valley. They are totally satisfied. They do not want to react with anything else. You cannot burn water. For the exact same reason, you cannot drop a rock that is already sitting on the ground. There is nowhere lower for it to fall. But this brings us to a brilliant practical question. If water is just chemical ash, how does it actually put out a fire? If I throw a handful of dry gray fireplace ash onto a burning log, it doesn't extinguish the fire. The fire just burns around it. So why is water the ultimate fire killer? Because water is the greatest energy thief in the natural world. A fire requires heat to push the next atoms over the activation barrier so they can snap together. If you remove the heat, the chain reaction halts and the fire dies. When you spray water onto a burning piece of wood, the water molecules land right on top of the furiously jiggling, burning carbon atoms. To turn liquid water into steam to boil it, you have to violently tear all of its millions of magnetic hydrogen bonds apart. And tearing bonds apart requires a massive, ridiculous amount of energy. We call this the latent heat of vaporization. The water acts like a quantum vacuum cleaner. It violently sucks the kinetic energy straight out of the carbon atoms, using that heat to tear its own internal bonds apart. The wood drops in temperature incredibly fast. The water absorbs the heat, turns into steam, and flies away, taking the fire's precious energy with it. Suddenly, the carbon atoms in the wood are cold. They no longer have the speed required to get over the energy barrier. The fire is physically frozen to death. But water doesn't just freeze the fire, it suffocates it. When liquid water flashes into steam, it expands by a factor of 1,700 times. 1 cup of liquid water violently explodes into 1,700 cups of expanding gas. This creates a massive physical wall of steam vapor. It physically pushes the aggressive, hungry oxygen in the surrounding air away from the fuel. It creates an impenetrable blanket of inert gas. Water kills fire through a brutal two-pronged attack. It robs the fuel of the heat required to react, and it builds a physical wall to starve the fuel of oxygen. It is the perfect extinguishing agent. But I know exactly what the engineers and the tinkerers are thinking right now. You say, wait a minute. If water is made of hydrogen, which is an explosive fuel, and oxygen, which makes fires burn, why can't we just build a car engine that runs on water? Can't we just split the water apart and burn it? This reveals a profound misunderstanding of the laws of thermodynamics. Yes, you can split water using high-voltage electricity. This is called electrolysis. You can capture that hydrogen gas, put it in an engine, and burn it. So why don't we do this to solve the energy crisis? Because you are trying to cheat the universe, and the universe does not get cheated. Remember the cliff. Water is the boulder at the bottom of the deep valley. To split water into hydrogen and oxygen, you have to physically push that massive boulder all the way back up to the very top of the cliff. You have to inject energy. The absolute ironclad law of the universe is that it will always take more electrical energy from your battery to rip the water apart than you will ever get back when you burn the hydrogen. You lose energy in the transaction. You can never use ash as a fuel source because unburning the ash costs more energy than the fire will give you. However, there is one mechanism on Earth that actually achieves this miracle, one system that successfully unburns water on a massive global scale. Plants. Trees are engaged in a constant miraculous process of reverse combustion. A tree acts as a massive biological solar panel. It waits for high-energy photons of light from the sun to travel 93 million miles through space and smash into its leaves. The plant uses the brute force kinetic energy of the sun to perform electrolysis. It uses solar energy to violently rip the water molecules apart. It takes the explosive, highly energetic hydrogen and it binds it to carbon to build its own branches, its leaves, its physical structure. A tree is quite literally a monument to unburnt water. It is a tower of stored solar energy, holding volatile chemicals apart, waiting for a spark. And when you chop that tree down, put it in your fireplace and strike a match, you are simply letting the hydrogen and carbon fall back down the cliff, snapping back together with the oxygen in the air, releasing the stored sunlight as a warm, flickering glow in your living room. When you finally understand this, the world stops being a collection of random liquids and solids. It becomes a beautiful, mathematically perfect ledger of energy. To help you permanently wire this into your brain, I've put together a free digital framework for you. I call it the Feynman Energy Ledger. The link is the very first thing in the description below. Get it, print it out, and start decoding the hidden energy matrix of your reality. So the next time you turn on your kitchen tap and fill a glass with clear, cool water, pause for a second. Look at it. Do not look at it as a simple, boring liquid. Look at it with the eyes of a physicist. Realize that you are holding the cold, exhausted remnants of an apocalyptic cosmic detonation. You are holding a substance that has survived the absolute most violent chemical collisions the universe can produce and has finally come to rest at the bottom of the quantum valley. Water puts out fire because it has already survived the flames. You are drinking the ashes of the universe. And that is far more magnificent and far more terrifying than anything your common sense could ever invent. If this video successfully broke your kindergarten common sense and shattered your reality, hit the subscribe button. Your brain wants to go back to sleep. Don't let it. We have a lot more comforting illusions to dismantle. I'll see you in the next one.